The recording has begun. So this upcoming Monday, and what today is going to be is basically an info session. I'm going to talk about some of the items that are on the review guide, and I'm going to draw some things out and show you some of the calculations that I'm thinking about. Um, and to first show the study guide. This study guide is up on your Canvas page. It's been there for a little while. I think I posted it last week. If you haven't had the opportunity to look at it, this is basically the rundown. What are, like taking it from the top, goes back to I think our second lecture, where we talked about chemical properties and physical properties. And there are some words that are good clues whenever you look at a chemical or a physical property. For instance, if something burns, that's a good indicator of a chemical change, because what's happened to that something is it's broken down, it's burned, it's changed into something like carbon dioxide and water. So these are all like, you know, these first three items, those are going to be good questions, or those are going to, kind of be like low-hanging fruit questions. An example, and now I'm going to switch over to use to share my screen that I'm going to draw on. But I just want you to know that I'm going to be kind of going question by question or item by item on the study guide. So the first few would be about chemical properties or chemical changes. And so what I can think of as a question right off the cuff of, a multiple choice question would be something like, which of, okay, there we go. It's a little bit delayed for me there. Sorry about that. Which of the following is an example of a chemical change? And simply, okay, I think that I'm getting a little bit of a delay. And okay, there we go. Which of the following is an example of a chemical change? And these would be something like, let's go with option number one, ice melting. Option number two, milk curdling. Option number three, then it would be milk curdling, wood being cut, and then maybe last but not least would be, actually, I'll just stop right there. Three options. I would expect for most of your multiple choice questions to see at least four different options, but I feel like I'm kind of getting the point across with these three. Ice melting. It's changing states. It's going from a solid to a liquid. Wood being cut. That's one where I think that people might be like, oh, but what about, our bonds of that wood being broken? Well, if you think about it like that, that's kind of the same thing as the ice melting, because it's going from like one branch or one board to two separate boards. They're still boards. They're still the same thing. They're just smaller versions of the same thing. Whereas milk curdling or milk spoiling or something like that, typically, go ahead and add to the chat if you'd like to. What is something that goes along with milk curdling? What's like a thing that you notice when milk goes sour or it curdles? Is there anything that you can, when you see milk that has curdled, do you notice anything about it? It's chunky. It separates. Yes. Yes. The physical, like the consistency of it changes. It stinks probably. Those are properties that have changed, chemical properties. Like when you smell something, that's an indication that, well, something about this has changed. So expect a question like that. An alternative way that I could ask that question is rather than it being a multiple choice question, it might be a multiple answer question where I would say, select all of the following. So when you see something like that, be kind of thoughtful and ready for that sort of question. That's the sort of question where if you select all of the examples that are, if I were to change this, I'd say select all of the following that are physical. And I'm going to change this to select all of the following. And then what I would expect you to do is select this one and this one. You'd select those two. I'm not doing those as like decoys, but I think that I like questions that ask you to select all of the above or all of the correct answers. I just don't want to see somebody who makes the mistake and that they only selected one of them. So that's one thing to keep or to be thoughtful of and remain aware of. Okay, then after that, we've got, can you convert a number from complete or full notation to scientific notation? Number 5, can you evaluate a number's size based on scientific notation? What is meant by a negative exponent when writing a number using scientific notation? And what about a positive exponent? Okay, so I'm going to take these 3 and show you kind of what I'm thinking about with that. So what I want to see is basically write the number 24685 in scientific notation. I just wrote that, but my computer is going slow right now. In about 3 minutes, it's going to be going considerably faster. So how do we write this using scientific notation? Okay, so we read this number as 24,685. If we want to write this in scientific notation, what we've always got to do is we want to put one digit and then the decimal place. So this would be 2.4685. Okay. Now, what we need to do after that is we need to say, all right, well, we're going to use an exponent times 10 to the, okay. Now the question is, how many places did we move that decimal? The decimal was originally here. So we moved it 1. Perfect. We moved it 4. So the question is it a positive 4 or is it a negative 4? Well, remember, we're taking this number and we would translate that to what the value actually is, which is 24,685. So that would be a positive exponent. Now, if I were to give you a number like this, convert 2.4685 times 10 to the negative 4th to complete notation, or complete or full notation. That is going to be, all right, well, I've got a negative exponent. I'm going to move that negative exponent. So if you're provided with that exponent or times 10 to the whatever, that's when you move to the left or to the right. So what we would do is we would imagine we're moving this. Ryan, that's absolutely right. So you always want to include a decimal, or you put one number, then a decimal, and then any remaining numbers. So we'd rewrite this by moving the decimal one place, 2, 3, 4. Well, there's nothing there, so we've got to fill in with zeros. So even this, writing in complete notation, I'm sorry I wrote it off the screen there, but it would be 0 point, and then we've got 3 zeros, and now 2, 4, 6, 8, 5. So those zeros, this like when we write with complete notation, yeah, we do want to include this 0 in the ones place. Just to kind of clearly indicate that it is a 0 there as opposed to any number there. So one of the questions that you should probably expect would be something like a comparison between 2.4 times 10 to the third, or 24,000, or yeah, 240,000, 2.4 times 10 to the 15th, and 2.4 times 10 to the minus 5. Which one of these numbers is the smallest? That would be a reasonable question to ask. Okay, well, the smallest number, okay, we've got 240,000. Okay, noted, got that in my head. I want to compare that to 2.4 times 10 to the third. Okay, 2.4 times 10 to the third. I'd move this 3 places, so 2, 4, that would be 1 place, 2, and 3. 2,400. Okay, so now what I can do is kind of cross this out mentally. 2,400 is a smaller number than 240,000. So if I'm going through and I'm kind of ranking them largest to smallest, I can also immediately cross out this times 10 to the 15th, because times 10 to the third gives me 2,400. Times 10 to the 15th would be a crazy big number, more than 1 billion. So I don't need to worry about that. Which brings me back to, I'm really considering this and this, 2,400 or 2.4 times 10 to the negative 5th. Times 10 to the negative 5th, I'm moving my decimal, 1, 2, 3, 4, 5. So this would be 0.0000024. That would be your smallest number. Anytime you see, if you're asked about a small or a large number, if you see a negative exponent, that's probably going to be one of your leaders as the smallest possible number. So be able to, discern between, or like be able to look at these numbers and say, okay, this one's bigger than this one's smaller than this one. Be able to convert between scientific and full notation. If I give you the number in full notation, can you convert it to scientific notation, and vice versa? Because there will definitely be questions like that. All right, now the next items on the conversions. Can you convert numbers, or sorry, items 7, 8, 9, and 10? These are all about conversions. These conversions being using the prefixes. And conversions. So minutes to seconds. And then centimeters to inches. And then temperature, Celsius, to Kelvin. And with all of these, if you can convert from minutes to seconds, can you convert from seconds to minutes, inches to centimeters, Kelvin to Celsius? I'll talk about the prefixes first and then go on. So the prefixes, the ones that I think are most important for you to know about are your base unit, which your base unit, I'm going to use liters, because I think everyone has a sense of what a liter is. Like you can go to the gas station, get a 1 liter Dr. Pepper. Then a kiloliter. This is equal to 1,000 liters. Okay. So I always talk about everything as a comparison to 1 liter. Now, smaller than a liter would be something like a centiliter. And there are 100 cents in a dollar. There are 100 centiliters in 1 liter. After a centiliter, there is a milliliter, which I'm just going to use that lowercase ml. There are 1,000 milliliters in 1 liter. Next up, below milliliters is microliters, which we define this as that character right there that looks like a U, UL, or microliters. It's called mu. 1,000 microliters is equal to 1 milliliter. Then you kind of have this like stairways or stepwise connection. Well, there's 1,000 microliters in 1 milliliter, and there's 1,000 milliliters in 1 liter. So a question that I like to ask is, how many microliters in 6.2 liters? And the way that you do that is you say, okay, 1 liter is 1,000 milliliters. So I'm going to multiply this by 1,000. What will that get me? That gets me 6,200 milliliters. If I'm asked about microliters, what should I do with that 6,200? Add to the chat what you think I should do. Maybe I should divide by 1,000? Or add 1,000? What do you think? Got 1 vote for divide. Well, if I divide by 1,000, that will bring me right back here. Kevin, you're absolutely right. I need to multiply. I need to multiply by 1,000 because because 1 milliliter is equal to 1,000 microliters, and that microliters is what I'm trying to figure out. So I can multiply that by 1,000, in which case, now basically what I've got is 6,200, and then essentially all that I'm going to do is add a couple of zeros to the end of this. And that means that's what I've got. Okay. So make sure that you know how to, like, if you have this right here, oh, darn it, Joel. If you have that and you know how to use that, you're going to be in great shape for this. Be able to go from in one direction to the next. If you have 1,000 microliters, or if you have, let's say, 9,600 microliters, what's that equal to? Well, that's equal to, divide by 1,000, 9.6 milliliters. Okay. Now, next up, minutes to seconds. How many seconds are in a minute? Add that to the chat. I think it's 12, isn't it? Is it 13? Oh, 60. You're right. You're right. You're right. It's 60. Okay, so 60 seconds. So if something takes 4.8 minutes, well, that 0.8, that is a fraction of a minute. So you're just going to multiply minutes, not milliliters. Multiply this by 60, and you get the number of seconds that are in 4.8 minutes. Centimeters to inches. Well, 1 inch equals 2.54 centimeters. Then last but not least, our last conversion here is Celsius to Kelvin. if all that you need to do is you need to take whatever degrees Celsius and add to that 273.15. So if it's 30 degrees Celsius, then it's 303.15 Kelvin. All right, so those are big conversions. Now, up until now, I haven't announced this, but we've got 68 people in here. Can you give me a thumbs up to confirm that you're listening right now? Because this is a very important announcement. I'm going to expand my chat window so I can see lots of thumbs ups. Okay. Oh, we got double thumbs up. Okay. Okay. This is good. This is good. All right. For this exam and for our exams moving forward, you're going to be allowed to use a single, just one, 3x5 index card. I've got one right here, 3x5 index card. And you can write anything on that you want. The requirement is that at some point during the exam, you'll be asked to hold it up to show that 3x5 index card. You can write on the front and back. Then what you'll need to do is you'll need to scan it in and submit it as an ungraded assignment. So you will be able to use a 3x5 index card for this exam. In addition to that, you can obviously use scratch paper that is blank that you write on during the exam, and a calculator, but no phones or anything like that. So for this exam and all future exams, you can use a 3x5 index card. Okay, happy everyone was listening for that. I think that will probably be, it's always helpful to have that just to, if nothing else, alleviate a little bit of stress. Because yes, you're going to scan it in after the exam. And it doesn't have to be a scan. You can take a picture of it, throw it into a Word document, or just upload the pictures of it. Yeah, I'll upload pictures. No, the exam it's all on Proctorio, which is why we had that quiz that was on Proctorio, because this class is 100% remote. Yes, you can absolutely use blank scratch paper. Are there any other questions or before I go back to working through some example problems? Yep, you can use the front and the back. Yep. Absolutely. Okay. Well, I'm happy that I got to announce that. So now I'm just going to go back to the study guide. We've gone through basically 1 through 10. And if you have any questions about that or you wanted to review it, I'm going to post this on our YouTube page or our Canvas page a little bit later. So items 11, 12, 13, and 14 all relate to density. So I'm going to pull up a new blank slide here. Now, if you remember density, whenever I think about density, I always think about water. And then I also think about ice cream. Why? Because I like ice cream. But another reason that I think about ice cream is, let's say that I had this mug and I filled it to the brim with water. And then I got an exact same copy of this mug and I filled it to the brim and packed it as tightly as I could of ice cream. Which one of them is going to be heavier? Go ahead and answer in the chat if you'd like, the water or the ice cream. Which one's going to be like tougher, or not tougher, but which one's going to have a little bit more heft to it? The ice cream. Absolutely. Because ice cream's like rich, it's creamy, it's got a bunch of nutrients in there. Now, is it going to be am I going to be like, oh, I can't lift this ice cream? No, I'm going to be like, if I held them evenly, it'd be like the ice cream is like this and the water is like this. So it's a little bit, the ice cream is a little bit more dense, just as an example. So more dense. Now, that's an important thing to remember. So if I were to mix, oh, oopsies. If I were to, mix two different substances, let's say that I had a ice cube, an ice cube and water. When you put an ice cube into a glass of water, what happens to that ice cube? If you can easily add it to the chat, add it to the chat. An ice cube's going to float. And it's going to float because the ice cube is less dense than the water. Okay. So if you put a substance, so more dense substances sink when they're exposed to substances that are less dense than that. So like if you added honey to ice water or something like that, that honey is going to sink because honey is more dense than water. They're both liquids, but one of them is going to sink because of the density. So more dense objects sink. Now, when it comes to density, there's a calculation. Density equals mass over volume. Typically, the units that we use are grams per milliliter. Now, the density of water is 1.00 grams per milliliter. What you can use this for as a calculation is I could say, all right, well, here's the density for water, 1 gram per milliliter. If I had 325 milliliters of water, what is the mass of that water, of that volume of water? Well, you take the volume and you multiply it by the density, and you get, well, milliliters times grams over milliliter. That is going to cancel out, in which case you're left with 325 grams. Now, we can modify that a little bit, make the calculation a little bit trickier. Let's say that I had 325 milliliters of lead or mercury. Mercury is the substance that's found in some thermometers. Mercury has a density of 13.6 grams per milliliter. If you had 325 milliliters of mercury, you would set this calculation up the same way. 325 milliliters times 13.6 grams per 1 milliliter. I always like to think about this as, well, I've got 325 of these milliliters. My units, whenever I multiply, those units cancel. So it's 325 times 13.6, which by my top of my head calculation is something like 3,025 times 3. So it's like 4,200 grams. That's not an exact or precise calculation. I was just kind of trying to do that one in my head. It's a little bit more than that. So between 325 milliliters of water and 325 milliliters of mercury, well, that mercury, if you're holding each of these in your hand, that mercury plummets because that's super heavy compared to the water. All right. So this gets us through the first 14 items. What I want to go to now is go to some of those questions about subatomic particles. So this is item number 18. And I'm going to talk about the subatomic particles and basically the arrangement of an atom. First and foremost, we've got 3 subatomic particles. protons, neutrons, and electrons. And among those protons, neutrons, and electrons, we've got them all kind of arranged. The protons and neutrons make up something known as the nucleus. And those each have a mass. Protons, 1 atomic mass unit or 1 AMU, and neutrons, 1 atomic mass unit. Electrons have an atomic mass of effectively 0. It's very, very low, but it's basically 0 for all intents and purposes. Now, if we were to draw an atom, what we also want to take into consideration is the charges, the masses and the charges. So a proton has a positive charge, a neutron has no charge, and an electron has a negative charge. Now, to make up the nucleus of an atom, we've got protons, and I'm going to label it as neutrons. Now, what I've drawn right here is a nucleus. A positive, I'm going to go ahead and put a second proton in there. So we got 2 protons and 1 neutron. This nucleus has an atomic mass of 3 AMU. The next sort of question that I like to ask is, what's the charge of it? Well, my question, if I'm putting this in this box right here, I haven't drawn any electrons. So my charge of this is going to be +2 because I have 2 protons there. And you'll have questions that ask you kind of, here's a model that has been drawn. Answer these questions. So we've got 2 positive charges, 1 neutral, and then if I added an electron right here. Well, now what's my charge? It's +1. What about if I put an electron here? Well, now my charge is 0. What if I got a 3rd electron or a 4th electron? Well, that would be -2. Now, these electrons, I drew them outside the nucleus. That's important, but we had a way of identifying where they were a little bit more specifically. We use subshells. Now, does anyone remember the letters for the different subshells? If you do, add it to the chat. There are basically 4 different letters for S and P, and then there's 2 other ones. SPD, okay. Yes! Yes, I knew it. S, P, D, and F. Okay. We primarily stayed in the S and P orbital. So Ryan, you're right on with those 2. Now, they get more complicated. Does anyone remember the shape of the S orbital or the S subshell? I'll give you a hint. It starts with an S. Sphere. Perfect. Okay. Next up, the shape of the P orbital. I'll give you a hint. Or dumbbell. Perfect. Dumbbell. Wonderful. Okay, so am I going to ask you a question? What is the shape of these subshells? Totally reasonable, because the shape of those does matter. So that's a totally reasonable question. Now, with that also in mind, I might ask you a question about what is the electron? I'm going to erase all this over here. Electron configuration, or here is the electron configuration. 1s2, 2s2, 2p5. And I might say something like, here's the electron configuration. From this electron configuration, you'd be able to say, okay, well, it's got electrons in the 1s subshell and in the 2s subshell and the 2p subshell. If I were to ask you, and imagine that this is a neutral atom, what is this atom? What's the identity of this element? What you'd have to do is you'd say, okay, well, 2 electrons plus 2 electrons plus 5 electrons. We've got a neutral atom with 9 electrons. So you're going to have a copy of the periodic table on every question that relates to the periodic table. But from this, you'd be able to say, all right, well, if it's neutral, that means, and it has 9 electrons, that means it's got 9 protons, because those protons are going to be offset by those these electrons. So 9 negatives, 9 positives, because it is neutral. This would be the element fluorine. That's a completely on the table question for me to ask, because you know that 9 protons, that 9 is the atomic number. Of an atom. And that atomic number tells you the number. Atomic number is equal to the number of protons. Okay. Now, one other thing that we talked about with respect to our subatomic particles is we talked about isotopes. So isotopes are basically 2 atoms with different numbers of, and this is totally a reasonable question. This is a question that's ready to go. Isotopes are 2 atoms with different numbers of neutrons. If you change the number of protons, you're talking about 2 different elements. If you change the number of neutrons, then you're talking about the same element, but with a different mass. An example of an isotope would be something like hydrogen 1, hydrogen 2, hydrogen 3. These all have unique names. They're hydrogen, deuterium, and tritium. They all relate to the different number of neutrons. Okay. I think that I'm going to stop right there, because that hits on most of the high points of what I'm looking for. This is not completely comprehensive. The study guide is comprehensive. So I suggest that anything that we did not cover here, but is in the study guide, all of the lectures are up, and the study guide is organized based on, the sequence that we covered things. So if you're like, oh, I looked at item number 28, given a structure, can you write the formula of a molecule? Oh man, where's that? Well, that's going to be from this most recent Wednesday's lecture. What I'm going to do is I'm also going to stop my share, and I'm going to escape out of this PowerPoint. I'm going to keep my annotations, and I'm going to upload this presentation with these annotations. Now, what I'll do is I'll open the floor to any questions. You're welcome to ask a question through the chat. I've got the chat open, or you can unmute yourself and ask that way. The exam is probably going to be 25 questions. So that puts roughly like 2 minutes per question. The exam will open at 9:30 in the morning and will close at 11:30 or 11 p.m. on Monday. Can you explain the question? What information? Okay, so Dylan, I'm going to answer your first question first. Is it all multiple choice? It's multiple choice and multiple answer. So a multiple answer question would be like select all of the true statements. So there would be like two statements that are true of the five or something. Now, can you explain the question? What information can you gather from a molecular formula? So what I'm looking for there would be something like if I gave you a formula, you'd be able to tell me how many carbons there are, um, how many hydrogens there are, how many total atoms there are. That's sort of what I'm looking for there. Does that answer your question, Kevin? Great. Is displaced volume the volume change when something is put in water? Yes, it is. So, here I've got a baseball. And if you went back to like um Piranha, yes, you can take the exam between 9:30 a.m. and 11 p.m. If I took a baseball and let's say I filled this coffee mug up all the way and I knew that this coffee mug had, 525 milliliters of water, drop the baseball in, the water that overflows, if I measured that, I'd be able to say, okay, well, it displaced 125 milliliters of water. Therefore, the volume of this baseball is 125 milliliters. That's one way. Yes, the exam is timed. You have exactly 50 minutes. If you have an accommodation for additional time, I need you to email me so that I can make sure that I include that in your testing. And then I'll bring this up again. You can use a 3x5 index card, um, and you'll be able to use scratch paper at your desk and everything like that. But that scratch paper has to be clear. So it's not an open note. This is not an open note exam. That's correct. There is no Zoom meeting on Monday because you have your exam. Molecule versus compound versus element. Okay. Um, so displaced versus displacement, they're effectively the same. So it would just be this, 15 milliliters is displaced. And so the volume displacement is 15 milliliters. A molecule, okay, so I can use the whiteboard to answer this. Is that what I'm looking for? I don't think so. That's not what I'm looking for. Whiteboard. Okay. Okay, um, so an element would be something like H2. So you'd see it depicted like this. Those are two hydrogen atoms that come together that are an element. They are the exact same thing. This is also a compound. And this is also a molecule. A molecule of H2 made up of two elements. Now, if I were to get something like let's go with water, the formula is H2O. This is two different atoms, hydrogen and oxygen. As a result of that, it's not an element. It is, however, a compound, and this is also a molecule. Does that help, Caitlin? So a compound is two different atoms. Yes. Close my whiteboard. Okay. Um, Are there any other questions? Because I'm going to be posting this a little bit later today. This PowerPoint and this video, I'll post these before the end of the day. I would go through the study guide, go through the study guide and, try to come up with individual questions. Look at the questions that we had during class. If I were you, I think the sequence of my study would be I'd look at the study guide and basically rank everything 1 to 5. Like one, I feel, or I'll make it simple, 1 to 3. One, I feel great about it. 3, I have no clue what that's talking about. So I rank everything and then I'd be like, okay, well, I'm going to focus on, make sure that those things that are ones, make sure that I've got those right. So then what I'd do is I'd look back at the PowerPoints and I'd say, okay, well, I understand this. I understand physical change. I'm great there. Then if there's something where it's like, I know that I can answer all those questions, then what I'm going to do is I'm going to go to the things that I've ranked number 2. And say, okay, well, those things that I marked number 2, that is just like, I need a little bit of clarification. And that's leaving the things that are number 3, the lowest rank. I'm leaving those until the absolute end because it's, I think that it's better to really fortify what you do have a knowledge of and bring up the things that are close to being brought up as opposed to those things that you're just like, I'm totally lost on that. So that's what I would recommend. And then, for those things that you really don't know well or you're really struggling with, I think what I'd do is I'd go to the PowerPoint and then I'd go to the YouTube videos and scrub through those. You can watch the YouTube videos at 2x. But I would scrub through those and see the explanations that I gave on those. And then if that doesn't clarify it, just shoot me an email and say like, hey, can you do this? Or what does this mean? And I will do my best to respond to all the emails or everyone's emails by, 5 p.m. on Sunday. But if you send it after that, it's a little bit less likely that I'm going to answer them. And so, but anyway, I hope that you all do well in the exam, and I will see you again this will be Wednesday. So no Zoom meeting on Monday because you have your exam. And that's all through Proctorio. Have a great weekend, everyone. See y'all.